everyone. Thank you very much for being here today. Our Extreme Group project is actually research oriented, and it is dealing with human and computer interaction in the context of decision-making processes. Next slide. So we are a team of 4 students at IBM France Lab in Paris, and we come from different backgrounds. First, there is Manon and Guillaume, who study applied mathematics and statistics. Victoire, who does a Master of Management of Innovation, and finally me, who does a double degree program between an engineering and a business school. Now I will let Victoire introduce the project.
The technology we are dealing with in this research project is machine learning, and we focused our research on its use in decision-making processes. There are 2 main concerns regarding machine learning drawbacks. First, the flaws of the algorithm coming from the database provided to it. Then, the way people interact with the algorithm, especially when it gives wrong recommendations. Our work is not focused on databases flaws, but rather on the interaction between a human user and the ML-based recommender. ML-based algorithms are already used in decision-making processes in order to help them. We have studied the interaction in order to understand the phenomenon of collaboration that is created between a human user and the ML-based tool. And we are going to present you with our findings. Here is our goal, measuring the impacts of recommendations provided by an ML-based algorithm on the rationality of someone making a decision. So, to study human-machine interaction, we launched an experiment where each participant had to answer 20 questions. The participants were randomly assigned to the control group or the treatment group. In the control group, the subjects were asked to answer the 20 questions without any recommendation from an algorithm. Whereas in the treatment group, they were asked to answer the same kind of questions, but this time with a recommendation from an algorithm. So the participants in the treatment group were assisted during the whole experiment. We want them, for the treatment group, by following the recommendations, the score would be on average 77 out of 100, or about 15 out of 20.
So to make it simple, the first hypothesis we wanted to test, which is called H0, the recommendation does not have an impact on the subject rationality. So of course, if we reject this hypothesis, we have to accept the alternative one, which is the recommendation does have an impact on the subject rationality. But as you know, rejecting H0 doesn't give any information about the way the recommendation is impacting the subject rationality, but we will look at this aspect later with econometric models. So let's go back to H0. To test H0, we use 2 statistics models. So the first one is pretty simple. It's by considering that all the answers are independent, and so we can use the Bernoulli variable. And the second model, which is a little bit more complicated, is by considering that everyone has a degree of rationality. So float P between 0 and 1, 1 if you are the most rational person ever. So which is a continuous density model compared to the first one. And both statistic models reject H0 at 5%. So at this point of the internship, we made sure that the recommendation is not neutral in the subject decision-making processes. So the next step was to study the correlation between the subject answer and the recommendation. So to do that, we've used an econometric models, and we have looked at 2 particular events. So the probability, we wanted to quantify the probability of those 2 events. The first one is called the authority bias. So the authority bias, this is the probability that an individual who has a false recommendation in their interface will make a non-rational decision, knowing that if that individual has no access to that recommendation, they would have made a rational decision. So this probability calculates the way you are changing your mind in a non-rational way. The second event we want to calculate the probability of, this is the resistance of the subject, which is the probability that an individual will make a rational decision when they access a false recommendation, knowing that if the recommendation had been correct, they would have made a rational decision. So it calculates the probability of staying rational with a false recommendation. And so by using an econometric model, we were able to say that the probability of those 2 events are significantly different from 0. But before presenting you the result and giving you order of magnitude of what we just defined, let's take a look at the website Guillaume and Victoire designed for us.
So thank you, Manon. So to make the experiment that Manon just described to you, we first needed to build a platform. So given the current situation with the coronavirus and our need for quite a large amount of subjects, we decided on building a website. It would first allow us to reach many people easily, but more importantly, maybe it would allow us to measure many parameters very precisely. Those parameters concretely regarded time, how much time someone spent making a decision, how much time someone spent thinking about the problem. To build our platform, we used modern technologies like Node.js, and we were hosted on IBM Cloud Server. Slide, please. So we wanted this experiment to have clearly defined steps, each one with a different goal. The first part was simply a presentation of the experiment. We told the user what he would have to do, and we shared with him our general goal. This is also where the user gave us his general profile, what were his studies, what was his age range, etc. Then what you see on screen is called a tree map. It was a tutorial that made the user understand the dataset better. We gave him relevant information, depending on what group the user belonged to, and it was an interactive way for the user to understand the dataset. We allowed him to tweak the parameters of this tool, and it allowed us to spark interest in the dataset and hopefully make the user make better decisions. Slide. In the actual body of the experiment, the user had to take a series of 20 small tests. On each one, 3 steps were imagined. In the experiment that you maybe took, there were 2 groups of experimentees, each one with a different interface. So the first interface was the one that you are seeing right now on screen. It was the interface of the experiment group. It has 3 parts. The first part is the data on which you have to base yourself to make your decision. Then you have the recommendation from the algorithm, and finally you have the part where you make your decision. For the second group, so the control group, the interface was strictly the same, save for the recommendation of the algorithm that was not there. Lastly, once the user had made his decision, he has to give us some feedback. He had to self-evaluate and give his impression on the algorithm. By giving those questions, we could get an idea of how close of an interaction the users and the algorithm might have had, and how much the recommendation might have influenced the decision. At the end of the experiment, we got around 500 participants. It was a population that was large enough to allow us to outline some interesting statistical effects, and I'll let Rida and Manon present them to you.
Thank you, Guillaume. So one of the first model's results, as you can see, the control group has an average of 72% of correct answers, while the group with false recommendations has only 67%, and the group with true recommendations is up to 79%. Also, as the previous test rejected the hypothesis H0, we have the following conclusions. With the proportion of false and true recommendation, the treatment group performed better compared to the control group and the algorithm. Therefore, we can say that there is a collaboration between human and machine. Secondly, the recommendation is affecting the subject rationality. And finally, subject rationality is more variable with false recommendation, whereas subject rationality with true recommendation has the same variance in the control group and the group with true recommendations. I will let Manon talk you through the rest of the results.
So then regarding the econometric models, you have 2 types of results. So the table on the left are results similar to what Rida just said, but it's in probability, not in percent. So for example, if you are in the control group, the probability that you give a rational, that you take a rational decision is 0.72. And if you have a false recommendation in your interface, this is 0.72 minus 0.04. So this is exactly the same result, but what is interesting with econometric model, this is the table on the left, on the right side, sorry. You can see the authority bias and the resistance of subject in probability. We were able to calculate those probability by category. We have choose to show you by age, and as you can see, young people perform best as they have a low value for authority bias and a high value for the probability of resistance. You have to know that the experiment we've presented just here is only one part of what we have done. We have made other experiments to improve those probabilities, especially to lower the authority bias and make the probability of the authority bias lower, and the resistance of the subject higher. and we are actually doing a research paper on that.
Thank you, Manon. So the experiment we have launched concerned a specific bias with the specific parameters. But if you want to take the results of the project further, we can think of different use cases where we use the recommender systems, like auditing, CV screening and hiring processes, loan granting, and deciding of a prison sentence. All of these use cases use a recommender system powered by AI, and we need to ensure the rationality of the users. Therefore, we can suggest for corporations to implement a testing methodology for interfaces that use machine learning recommenders in order to minimize the authority bias that we can quantify with the probability P and maximize the user resistance that we can also quantify with the probability Q. In other words, the interface will be given arguments or some transparency that allows the users to make their own judgment while taking into account all past decisions. Next slide, please. So thank you so much for your attention, and we hope that that the topic has raised some interest and that you have enjoyed the presentation. Lastly, we want to thank again IBM France Lab for having us as interns during the summer. And if you have any questions, please contact Thomas Boudel in the email address on the slide. Thank you.